Welcome to this video in which we are going to explain briefly the functionality of a script that synchronizes the configuration between Kubernetes and Azure Firewall. Let's have a look at the use case. What we have here is a Kubernetes cluster that is deployed in a virtual network and exposes application via an internal load balancer. The intended traffic flow is that when an application user accesses the application, it first goes to the public IP address defined on an Azure Firewall. Azure Firewall inspects the request, and it forwards it to the internal load balancer with a destination network address translation rule, translating the public IP address into the private IP address exposed by the load balancer. The problem here is that Kubernetes cluster could configure multiple rules, load balancing rules in the load balancer, which would require multiple DNAT rules in the firewall. Keeping the load balancer configuration and the firewall DNAT configuration in sync could be a significant overhead for our operations team. So the idea here is to have an automatic synchronization so that when there is a new load balancing rule in the load balancer, that configuration triggers an event that is captured by event grid. Event grid can then notify external systems, for example, a logic app. The logic app will run a runbook, an automation runbook, which essentially is a PowerShell script. This PowerShell script will read whatever changes were done to the load balancer and apply the corresponding configuration in Azure Firewall. This could mean editing existing rules, adding new ones, or deleting load balancing rules. All right, so now that we have the background, let's see this in action. All right, so here I have Kubernetes cluster and I have some services configured. Actually, I have one service. This service is configured with a load balancer related external IP address, so meaning an IP address configured on a load balancer, a private IP address, which is exposed through a port. If we go to the corresponding load balancer in here, we see that it's that port, and if you actually want to see the IP address, you need to go to the front-end IP address here, which is the .33 exactly. This means that the firewall also has a DNAT rule for this. Let's refresh this page. And we see that the firewall has a rule that maps the public IP address 1234, which we saw in the diagram, to the load balancer IP address to the exposed port. Okay, so let's see what happens if, let's change that. What happens when the administrator decides to change the port of the service. In this case, it changes the port from 8080 to 8081. Let's have a look at the services. Now, the service is configured with the same IP address, but exposed to port 8081. What this makes is an event that will modify the load balancer configuration. So if we refresh the load balancer configuration, now we see the load balancing rule points to port 8081. This configuration change will trigger an event in event grid, and this will trigger a run of a logic app. The logic app, this particular logic app, is configured to react on event grid events that happen inside of the infrastructure resource group or the node resource group, which in my case it's this one, for configuration changes. And whenever that happens, it will create a job in an Azure automation account based on a script, a runbook stored in that configuration account, which is called Firewall DNAT config in this case. So if we go to that automation account to this runbook firewall DNAT config, and we refresh the triggers, we see that there's one just has been completed right now. And we can go to the output of the script, and what the script is doing is first authenticating to Azure, finding the relevant objects like the AKS cluster, the load balancer, the load balancers. Actually, there can be more than one. Finding the right load balancer, identifying the Azure Firewall policy that needs to be synchronized, and then going over the different rules in the load balancer as well as the different rules in the firewall, and making sure that each rule has in the Azure Firewall has a corresponding rule in the load balancer, and vice versa. So after this runs, if we go back to the Azure Firewall and we refresh this page, the DNAT configuration should have been updated with a new name. Let's see. And there you go. Now it's port 8081. Okay. So modifying rules works. Let's add a new service. So let's add a new service that is going to be called API2, and it's going to go to 8082. Exactly the same thing will happen. The chain of events will go there. Let's have a look at the services as we have it now. So now we will have two services, one exposed on port 8081 and the other one on 8082, each on a different IP address. Looking at the load balancer rules, we see now we have two instead of only one. And what we would expect is that script running. And let's have a look at the logic app, refresh. Okay, we have another one running right now at 12:20, and same thing in the with the script. If we refresh this, there's another one running right now, and eventually that script will add a second DNAT rule in the firewall here. So let's refresh this. There's not a refresh button here, so what I do is just changing menu, and sure enough, here the second rule appeared on port 8082, and with the second IP address, the .34, as you can see here. Right, adding rules works as well. Let's remove one of these services. Let's remove the second one we just added. All right, few seconds. And now we only have one service. Let's verify the load balancer here. Okay, only one rule, back to only 8081. And eventually the script will make sure that these two rules, the second one of these two rules disappears, and only the 8081 stays. We will have to refresh. We will have to wait until the script runs. And there you go. Only one rule left, for 8081, and the one for 8082 disappears. All right, I hope you find this script useful, and please make sure to open up GitHub issues if you happen to find any problem or you have suggestions to improve it. Thanks for watching.